Hello, hello, hello. DOS. EMU. Am I root? I think so. Today, clear. Today I want to go over again, Bibidaba, over our program again, and look at some more stuff. Okay? Now, let's say, not clear, CLS for clear screen. Let's say, first let's say, I am not the, I am not the end all to this info, okay? Okay? I am just a dude who likes to get really deep into what he's doing and figures out stuff, and that stuff seems to work. Okay? And I do not have a degree, alright, in computer science. But I got an understanding of what's going on. Okay? Some stuff I might say may not be 100% correct, but it's not 100% wrong either. Right? And if it works, it works. Okay, so with that in mind, a little disclaimer. I want to say debug. I'm going to debug my hello. I'm going to say debug hello. No, I'm going to say debug taco.com.asm. Right? Last time I told you guys about compiling, okay, and how assembler does not get compiled. That is sketchy and not really 100% true, okay? How it gets compiled I'll talk about later, but it's not really it's a little different. If you want to think about assembly language, okay, it gets turned into machine code. This is true. Okay, does it get compiled in the sense of every other language? That's kind of not true. Okay, if anything, if it did get compiled at all, it does not use the greater dependencies that we find with Java, C, and all those others. Okay, right? Can I list the size? I don't know. Size, maybe? Did that work? That's not gonna work, of course, that's not gonna work. But, if it does get compiled at all, okay, put it like this, it gets turned into something that the computer can understand better. True, okay? And when we type in the move instruction to move parts from a register to another register, we do have to run it through a debug, alright? Or we do have to, in a sense, maybe turn it into a machine code. And is that what compiling actually does? Yes, that is what compiling actually does. But we are not in the sense of what other machines do. So I'm gonna stop saying that. Maybe. Or maybe I'm just going to lie. One or the other. So let's say debug. We're going to debug or look at we're going to look at taco.asm. Okay? D for dump, and that is our program. Now, we look at our registers. Okay? Can I go step-by-step execution mode? I don't know. I don't think so. Okay? Let's say quit, and then we'll clear the screen. Pull tacos.asm up again. Dump. Okay? Now we can unassemble this machine, or we can unassemble this assembly source code, if you want to call it. It is source. We can unassemble this, okay? And we can see exactly what's going on through our machine, okay? Maybe I should have shrank that up a little bit. I don't know. But what address? This is not. Okay. Bit clear. Let's say tacos.asm. Unassemble. It's unassembling the source code. Okay. Clear. Let's say tacos.com, which is our executable file. Unassemble. There we go. Okay. Now, when we go into our tacos.com executable file, okay, keep an eye on these address spaces, okay? Remember where we are. These are the locations of our address. This is where our stuff is, okay? This is the stuff that we cannot seem to read, or that the computer does not seem to read at some time or another, okay? B409, BA0000. If you remember way back in like tutorial 3, I talked about 00, which was a null character or something like that, right? This is a machine code file, okay? .com executable is it turned it into machine code, okay? Okay. And if compiling does actually turn something into machine code, then this was just compiled, okay? But definitely not like the rest of them. A lot smaller, okay? With like hardly any dependencies. So if I debug the .com file again, and I'm going to unassemble it, and you can see exactly what we typed in the last tutorial, okay? You can see here that we moved our address assembler up to 100, right? And we typed in the instruction to move into the AH register. This is something I really like to talk about. AH register. I never signified or dignified a AH register that there was actually one that existed, okay? I did say there was a DX register, and we did look at, we see here that this is AX. How come there's an AX? How come we screwed up but yet we still succeeded? We didn't screw up. That was true. We did not screw up, okay? And what happened is that when I was talking about the high order bytes, low order bytes, there's two different parts to this register that we can split in half, okay? And AH is in the AX register, but the AX register is comprised of two lowers that you can add, okay? AH is for A high, and AL is for A low, okay? Now, this opcode got moved into the AH register, okay? It did not get moved into the AX register, okay? It got moved into the high. It would be here, okay? So 09 would be moved here. Can I do something funny like do that? I sure can, thank God. Alright, T is for trace. Now if you notice, there's a difference that happened here. This is the AX register before we actually executed this code. Up here, okay? This was our first, one of the first things we entered in. And we said move into the AH register 09. 09 is something called an opcode, okay? Opcodes are an operation codes, okay? And this opcode says to move string or a string. This refers to a string, okay? So that's telling the computer that you're going to move a string, okay? Now you haven't said where the string is or anything until you hit here, but this says that prepare for a string, okay? Or move in a string, or allot me space for a string, okay? Or get ready, here it comes, okay? That's for a string. Now 08 would be for a different type of thing, which would be a paused key press, okay? 01 would be something else, like a show maybe, or something. I could be totally wrong on that, and I think I am. But different opcodes do different things. Opcodes go in the AH register, or you could put them all across in the AX register. It's not advisable. Some opcodes such as if I was to type in, instead of 09, 3C. Okay, 3C is an opcode for create a folder. Okay, if I wanted to create a folder, first I would have to put into the AH register 3C. Now, I don't know if a folder can send back something, but I do know when you create a file, if you create a file, I think with 3.9, it could be a file. Like if you were to open up a file to write to it, you need to create that file, or at least put it in, this is called the accumulator register. Okay, an AX register. AH takes the opcode, okay, but the opcode sends something back called a file handler, and that has something to do with the flags down here. Okay, the flags will get set, but when your file handler comes back, your file handler will come back in the AL register. Okay, so the AL register is in this lower block here, AL for A low. But when you put in certain opcodes, it will give you back a handler, and that handler, you have to do exactly what it says. You have to handle that handler. Okay, and you have to then move that out of the way, especially say if you're adding things or something like that, or especially with files. If you want to create a file, first you have to create the file that you want to write to, then you have to open it, and then you have to write to it. Okay, but during that process, it requires things come back into this register from the computer. Okay, and you have to do things with those things, or if not, you're going to overwrite your data. Okay, and that is not cool. So that's what that is. I'm happy that T worked out fine. Like I said, this is the AH register, A high. Okay, we did not put it all the way across the AX register. All right, but we did put it in the high, which is AH. Okay, and A low. You also have two BX. BX register has a BH or a B high and a B low. CX has a high and low, same thing. You can see here what happened here. CX, I didn't add anything to CX, but the computer itself, this was not in my code. This right here was my only bit of code that I wrote. Okay, this other stuff here is written by the computer. Okay, all this other stuff here is written by the computer, and it's doing, what is it doing? It's doing certain things in the DI. It's moving AX into DI, right? It's testing it with an OR function or OR statement. Okay, OR gate. Okay, it's the AX. You see here J and Z, or jump not 0 to 113. All right, so up here must be some type of function that it's pointing out or whatever like that, but this is the other stuff that gets added. Okay, and that's what we can see. Okay, now the DX register, why did I put this string? Okay, why did I put this address of this string in the DX register? I could scroll down, as you can see here, that our code segment, data segment. I get them backwards all the time, and I get them backwards all the time. And down here, these need to change. One of these is right. I'm going to say this is the code segment. I could be wrong again. This address here, you can see here that at 0200 we actually have our string. We actually have our Hey Joe. Okay, well, we're not there yet. Alright, so we don't see anything yet about what that is. So this is not the full program. This is just enough on our screen. Okay, but the DX, we sent that string to the DX register. Alright, we sent Hey Joe to the DX register. Why did we put it in the DX register? Okay, the DX register does things like handles strings, data words, stuff like that. Okay, the AH register is somewhere where you do not want to put anything as far as bytes, as far as data goes. You're talking about strings and words and everything else like that. Okay, the DX register is allotted for that. The AX register is an area that you need to designate only for opcodes, and because what happens is when you send an opcode, like I said, certain files send back certain things, they come back to the AH register or the AL register. Some of them come back to, a lot probably all of them come back to AL register, okay? And they deal with flags down here too. But your file handler is going to come back to the AL register. So you don't want to go in there and type hello world into the AL register. I don't even know if you can type in hello world to the AX register. But it's an accumulator register, okay? This is where your opcodes go and where all your stuff like that goes, okay? So you want to designate this only, not for any type of, say, any type of string work or anything else like that. The same thing with BX register. I don't like to put any type of strings or any type of words or any type of stuff in the BX register. It's different than the AX register. It's not an accumulator. You can probably send flags to the BX register, but by nature, by natural state, by default, I think they all come to the AH register. Okay, so when you send things and they go somewhere and they're expected to come back to a certain position, you don't want whatever you have in this that should be in some other register where it should not be, because it will be overwritten. Okay. Now the CX register, for example, the CX register, especially which I'll get into later, when I'm creating a file or something like that, you have to create the file, okay? You have to send a name to the file, okay? You have to move, you have to use the proper opcodes to actually create a file and name the file, and then you actually have to give the file permissions, okay? So you have to, permissions example, 0 is for like write permissions, like you can have write permissions, whatever like that. Read permissions would be maybe a 1, stuff like that. Those permissions would go in here, or basically the parameters to the functions that you do. Okay, when you create things, if you do programming and you something takes a parameter, okay, parameters may go into the C area, okay, and they can go into the C low or C high. They don't have to take up this whole slice, okay? But with a DX register, you could put it in a DL, but a lot of times bytes that we're writing as far as strings go, they may be so big that we need to take up the DX, the whole entire DX register anyway. So that's why I put it in DX, and I didn't say DL, D high, or anything else like that. Okay? Super deduper. Int is not an integer as like with C program or anything else like that. Int is actually an interrupt, okay? And when you need the computer to do something, for example, if you need the Windows kernel to do something, say to call kernel or print to screen, I don't know if it's print to screen, but if you need it to do something, you have to signify interrupt, okay? You have to stop the mechanism from rolling. Stop the ball from rolling, and interrupt 21. Okay, now interrupt 21, there's different interrupts, starting with 0 all the way up to whatever. Okay, and if you can go get look at the bottom of my screen, go get Ralph Brown's interrupt list. Okay, Google it, you'll find it. Okay, this is DOS. This is DOS. Okay, DOS. There's a big thing with interrupt 21 and DOS, and how interrupt 21 is not anything like it should be with other languages. It seems to only be with DOS. Okay, now if I was to put interrupt 21 on a Linux machine, it would not stick. Okay, I would get all kind of errors and everything else about that. So this is specific to DOS. Okay, now is it 80? I think it is 80. Interrupt 80. See, they use the same syntax. You saw it. Linux uses the same syntax, same procedures and everything else like that. The only thing of course they use the same processor. Okay, everything here is the same in Linux. The only thing that is different is the opcode. That's all that's different. Okay, your addressing is the same. Everything is the same. The only thing that's different is opcode, and especially this opcode of int21. Okay, I think with Linux it's int80. Alright, but when I get into more Linux assembler, I'll definitely learn those better. But interrupt 21 is a problem, and later on we'll change that. But for right now, we'll stick with interrupt 21. Interrupt 20 signifies the end of a program. If you don't throw in an interrupt 20, you're going to get, you could get, not with a simple hello world program, but if you don't throw in an interrupt 20, you will get a lot of errors, especially if you have a lot going on, you know, because your code does not know where to end, okay? And it's going to try to keep going, and it's going to drag, okay? And you're not going to be able to run it. It's not going to happen. You're not going to get past this, okay? And you see here at 109 that we popped on the stack, popped off the stack, what's in CX, okay? I don't know what was in CX, okay? But this is your computer doing stuff, okay? So that is pretty cool. That's pretty cool. We are very deep, very cool, very low. Jump, okay? Jump. We'll go over jumps. Compares. It's like an takes, you know, if 1 equals 1, do this. If not, then don't do anything or do something else. Jump is 0. Okay. We have or. All right. Which this is. It just compared. You know, do this or do this. You know what I mean? All right. It's not like do this or do that. It says do this or do this, or putting emphasis on that you can only do this. Okay. And that's pretty much it with this up here. Okay. As far as execution goes, let me clear the screen up again, and we'll run it back through, and we'll say something like debugtaco.com. Right now we're in the debug mode. We're going to say disassemble or unassemble taco.com. It's not the whole file, it's just this much. Okay, it's just this much that we can flop out at one time. We can hit it again and we can see it again, or we can see the rest of the code. We can leave off at 11F and go on. Okay. Now let's say T. We're going to trace our execution. Alright, it's stuck. If you remember in the last one, what we did was this AX register was at 0. If you don't remember, please go back and look at it. Alright, it's kind of important. The problem is with a lot of virtual machines, and especially with DOS, because DOS is a sucky ass system. The refresh rate on this thing is not that great. So I exited the program and I dumped it again. And it's classic Windows to kind of not show me exactly what I want to know. Okay? You may find out when you're running, if you run an emulator, you may have some problems. I had a lot of problems with this emulator, and I still have some problems with it. And I have a lot of problems with the DOS 7.1 OS that I put on another computer. It's a shitty system. It's a really shitty system. Alright? The way that they allocate memory is not like, I mean, if you come from Linux, you are not impressed by what's going on here. Okay? And we'll talk about that later. Especially with jumps. Alright, you can only jump so far, and I will talk about that later because that really killed me on something, and it came to find out it was just with the file system and format and the way that DOS actually does things and frame buffers and everything else like that, which is completely retarded. Okay, so the AX register, and the last time when I dumped this out, and like 3 minutes ago, okay, was zeroed out, had nothing in it. Okay, and we saw that we moved into the AH register. Okay, the AH, which is A high, okay, which is, there's an A high and A low. We moved into that. The opcode is 09, and you see where it's at. It's in the high position. 09 is in the high position. Okay, now if we got a handler back, we will get that handler back in the low position. Okay, or unless we send it somewhere else. Okay, so that's pretty cool. Down here you'll see your next instruction to be executed. Okay, and if you look here, instruction pointer, this is also something here. This instruction pointer points to the next address to be executed. Okay, that's what that does. Okay, and you'll see that it's at this address here. Okay, let's hit key again, trace again for dump out some more. Now we will see everything stuck. Okay, the data segment here, you see here, this data register, had no data in it at all, okay? The next instruction pointed to 102, okay? And at address 102, what we said was move into our DX register, address 200, okay? And when we trace it out, you can now see that our DX register is changed to hold the value in memory location of that string, okay? 0200 is not the literal string, but is the address of the string, okay? And the instruction pointer showed that execution, okay? Now our next instruction is at address 105, okay? And this is what it is here. Address 105, we said interrupt 21, okay? So the interrupt 21 gets put in here. Well, this is our interrupt 21. Hit another T. Okay, and with T, everything, this is a trace. It said program terminated normally, everything is fine. Okay, the rest of the stuff I guess we're not going to get to see. Okay, but that is that. Now, quit, clear screen. That's all I'm going to go over, but I wanted to stress the importance of using AH and AL for different things. Okay, like I said before, there is also BX, which contains BL and B high. Okay, they are in backwards order. Okay, they are not in backwards order, but I wrote them that way. Okay, naturally high would come first. Okay, and stuff like that. All right. Next we'll talk about some more stuff with debug. If you ever have any problems, you can always hit debug, enter debug mode, hit the question mark, okay? And what you'll get is a thing to show you some syntax, okay? Okay. And we'll talk about more about disassembling things and looking at certain programs and this and that. We'll talk about actually how to say debug. We'll talk about how to dump, more about the dump function, okay? And we'll also, I can show you this real quick. We can say there is a command called fill, okay? Fill, and you're going to set the address range. I want to fill 300 to 400 with zeros, okay? Or fill is not spelled out, F for fill. I want to fill addresses, okay? Right now we're on address 0100, right? By default too, I want you to understand that by default, when you enter debug, it'll open you up, it'll drop you off into address 100, okay? So we can change that at any time. We can change that at any time by setting our addresser or assembler to 100, okay? Or we can say set address to 0, let's say 900, okay? And now you see here that we are at address 900, okay? We can set that at any time, okay? And by default though, debug will put us at address 100. So it's not really imperative that we type in address 100 all the time before we do code, okay? But it's a good practice to do that, just to know where to move the assembler and everything else like that, okay? Now, like I said, let's clear this up. Type in debug again. I'm going to use the fill command, okay? Let's dump it out. You see, by nature, by natural state, we're at the address of 100. This is in memory. This is not, you're not really, this is a memory allocated to you, okay? This is a space allocated to you. You can change stuff from here when you write to it, okay? But right now, when you type this out and you think you're doing some great code, which I have done in the past, and you know, think I'm going to go back and find it, it gets flushed out in memory, okay? So unless you want, in order for you to save things on the hard drive, you actually have to write to them, okay? So that's the difference. Now, we get dumped out at address 100. Well, I want to fill, use F for fill, and it takes a range. I want to fill the range of, let's say, 300, which is not visible, to 500 with zeros. Why can't I do that? Probably because it's freaking frame buffer. 200 to 300 with zeros. Fill 200, 500 zeros. Of course, that's not going to work. Fill 200 with zeros. Fill. Let's say fill one. Let's fill 100 to 150 with zeros. Oh Jesus. Fill 100 to 200 zeros. Alright, I'll talk about the fill command. But basically what happens is it fills all this stuff here with zeros in RAM. Okay, now you can fill it with zeros and then write it to your hard drive and everything is going to disappear. Alright, so that's that. That's pretty cool. There's other stuff too, like say RCX. Okay, you can change the contents in a register. Okay, we will say dump, right? And let's say quit, and then we're going to clear the screen to get it up higher. Let's say debug, dump. Okay, we dump that out. Now let's say R. If we said R AX, right? Let's say RAX. Right now, our register AX, we can change the contents of our AX register right from here, right now. Okay? And the way that we can do that is right now, well, it's asking for what to type in. Let's type in A, B, C, F. Okay? We hit enter. And if we dump it now, and we look at our RAX register, okay? Look at our RAX register. It contains the value A, B, C, F, okay? I wouldn't say it contains a string. I wouldn't say it contains a word. Okay, it contains a hexadecimal format of A, B, C, F, whatever that translates into. Okay? So you can change contents of any register, okay, from here. Okay? We can also use something called the enter command. Clear. Let's say debug again. We can say enter into the DX register at address 100 maybe. No. Enter DX or CS. Let's say enter CS 100 or code segment 100. Okay. So dump. You will see at address 100 FG is there. Okay, we can change individual bits or individual bytes. I'm sorry, bytes. We can change individual bytes at certain locations. Okay, so not only on the next one I'll show you how to fill. We can fill this whole thing with zeros. You can fill your whole hard drive with zeros if you want to. Okay, but you can. It's just like the DD command with Linux. You know how you can fill your whole hard drive with zeros when you want to get rid of it and you don't want people stealing your info after over in Nigeria somewhere. Okay. And why Nigeria? Because I don't know if you guys watch TV or not, but our waste goes to other countries. So in those other countries, they pick up. Look at India. They pick apart. It's a great scrap mine and platinum mine, and all the precious metals in our computers get stripped away in other countries. Okay, and our hard drives go to other countries, and I'm sure they plug them in. Why wouldn't you? I would. I plug in anything I find. Okay. So at the address of 100, we see that it possesses this value, F6. Okay. Now we can change that value at CS by saying enter at CS100, that location F6. Let's change it now to 99. Okay. And if we hit enter again, oh, it's going to break us out. There's a way to keep it going too. Alright, now let's dump that address 100 again. Okay. Let's say dump 100, that address. Remember this. Remember the previous address. The previous address at 100 contained this value at 100 was F6. Okay. We changed it from F6 to 99. Okay. Now we need to dump it again to look at it. But when we dumped it, it kept going. We need to set it back. We need to specify to it. We want to dump address 100 again. Okay? And let's look at it. Alright? Here it is. Address 100 is changed to 99. Okay? You can change individual bytes of information. Okay? You can zero out individual bytes of information. Alright? So that's what that is. We'll get into that more later on. And this is a great, great time. Right? Right. That's all I'm going to do. You guys have a great day. Thank you for watching. I hope this is working for you. So I'm having a lot of fun. 5079. Ooh. Peace out, guys.